All right, jump back into the notes from yesterday on the normal curve, and we use a calculator. So same notes as yesterday we're going to start with. So we said yesterday that they used to give us this normal distribution on our exam, and they don't anymore. So we don't have to memorize all of those percentages, which is great, but we do have to memorize the three that we talked about. We have to know one standard deviation is 68, 2, 95, 3, 99. So 68, 95, 99. Now, the rest of this can actually be done on the calculator, but I didn't just want to jump to the calculator without understanding like what we're finding. So someplace if you got room at the top here, let's jot this down on where we're going to use the calculator and what it's called. It's definitely in a spot we haven't looked before. So if it says normal distribution, okay, you're going to circle the word normal, and then your brain's got to say, I'm going to use my calculator and use this thing called normcdf. Don't ask me what CDF stands for. I don't really know. Cumulative, I don't know, distribution, frequency, something like that. normcdf. So when you see normal in a question, you're going to say, oh, that means go use normcdf. Now, again, this is in a weird spot. So let's jot down where we're going to find it. We're going to hit second. And then there is one button that's labeled distribution, I think. It might be DISTR. Okay. Now, there's a bunch of information you have to enter in here, so I just want to jot down what we have to enter. You have to enter a lower bound, an upper bound, and then you need to enter the mean. Now, they don't use X bar when they're talking about this mean. They use the mu symbol, I believe, when they're talking about the mean. And then your standard deviation. Okay. Now, there is one catch. If you don't have a lower bound or an upper bound, you have to use a number. If they don't give you a lower bound and upper bound, like if you're going up forever or down forever, if you're going down forever, you're going to say -9, or like 5 nines, -99999. We're implying like negative infinity. And this, we don't have an infinity symbol on our calculator, so we're just going to use a bunch of nines. And if we want to go up to infinity, we're just going to go 5 positive nines, 99999, implying that we're going on forever. Okay, so if I don't have a bound, I'm using these numbers. So it may sound silly, but we're going to try to answer the same questions using the calculator now, and then we'll go through some extra ones in a minute. Everybody have all that? Yeah. This is going to be the symbol for the mean on this distribution, and our standard deviation is going to be the same.
I couldn't read what that.
Gotcha. Yeah, I scribbled. All right, flip the page and let's try. Well, let's pick something from the homework, maybe. Let's try. Let's look at number 4 from the homework, okay? So we had 1 through 5 last night. So it says data collected along lifetime is normally distributed. I want you to circle that word normally. So your brain's going to say, I can now use the calculator and use this normal CDF. The mean is 30,000 and the standard deviation is 2,000. So let's, if you haven't done so, let's draw that picture out, which I'm sure you already have. We have our mean in the middle. We said we always want our mean in the middle. And we're counting by 2,000s. So that's 32,000, 34,000, 36,000. I'm going to count down, 28,000, 26,000, 24,000. All right, now, I'm not going to worry about A and B at the minute. Let's talk about question C. What % of the tires have a life that exceeds 26,000 kilometers? All right, so we're going to mark 26,000 on our picture. which is 2 below. And if I want to exceed 26,000, I want to go from 26,000 and all the way to the right. I want to go exceed. I want to be bigger. So I want to go from 26,000 to forever. So I'm going to use that normal distribution now. So I don't need to add them up anymore is my point. So I'm going to hit second distribution. Distribution is right here on the variable key. Second distribution. There's a norm PDF and a norm CDF. We only use CDF in this class. Okay, if you took a stats class, then you get to use all these buttons, but we only use norm CDF in this class. Okay, my lower bound. So the lowest it's going is the 26,000. And it doesn't have a bound to stop it. It's going forever to the right. So that's when we're going to use all those 9s. 9, 9, 9, 9, 9, 9. The mean is 30,000. And the standard deviation is 2,000. Okay. So as we're checking our homework from last night, we just go down to paste. It'll put it on your screen and then hit enter. And it should spit out hopefully the answer you got when you added them up as 0.977, which obviously I would then make it a percent to say 97.7%. So you no longer have to add all those up. You're going to have the tool that's going to do it for you. But obviously, if we didn't talk about what we were doing yesterday, this really wouldn't make sense on what number we're finding. Let's try another one. Let's try number 5. The shelf life of a particular dairy product is normally distributed. So there's that word normal. So my head's got to say I see normal. I got to think normal CDF. I have a mean of 12 and a standard deviation of 3. So I'm counting by 3s. So I have my 15, 18, 21, 9, 6, and 3. So I want to know what percent to fall between 9 and 15. Now again, that's probably one you know off the top of your head, right? I went out one standard deviation, so I know that answer should be 68%. Let's just verify on the calculator. Pull up your normal distribution, norm CDF. Okay. The lower bound, I'm going from 9 to 15. The mean is 12, and the standard deviation is 3. So I'm just entering all of that in. Going to hit paste, and hopefully I get the 68% that we just said it should be. Okay. Try 12 to 15. Let's just keep playing on the calculator. Second distribution, norm CDF. I want to go between 12 and 15, it says. My mean is the same. My standard deviation is the same. Those don't change. Did you have 34.13? Should check out. All right, let's try C. What percent would be 6 days or less? So if I want 6 days or less, I'm going to 6, and then which way am I shading? Left. So my lower bound doesn't really exist because it's going forever this way, so I'm going to use negative 999 for my lower bound. So second distribution, norm CDF. Negative 999. I would put at least 5 in. You could put more, but at least 5. Upper bound is going to be 6. And then again, the mean and the standard deviation shouldn't change. Hopefully you had that answer on your homework last night. 2.27%. And we'll check one more. What percent would be 15 days or more? So I'm saying I'm going to 15, and then I'm going more. So in this case, my lower bound would be 15, and I would go up to 99999. Second distribution, norm CDF, 15, and then I'd go a bunch of 9s. I got 15.86%. So again, we're going to use this tool then instead of adding all those because they don't give us that anymore. So we've got this tool in our calculator to help us out. So start with 6. We'll put like 15 minutes on the clock. We're going to finish this page front and back. Start with 6. I'll get some answers up to compare in a few minutes. But draw out the picture once for yourself and then use your calculator to answer these questions. Everyone close to 8? On 8? On 8? Okay. So 8, you have to read a little carefully. It says in an Oreo factory, the mean is 40. The standard deviation is 2. Okay? And they want to know how many cookies are within 2 grams of the mean. So remember, when you see that within, that means you have to below and above, right? So I'm going to draw this one out again. So my mean is 40. My standard deviation is 2, so I'm counting by 2, so this gets me 42, 44, 46, what's that, 38, 36, 34. And I want to be within 2 grams of the mean. So that means I want to go up to 42 and down to 38. So you had to draw that out and figure out the lower and upper. They didn't just come out and tell you the lower and upper this time. You had to draw it out and say, I want to be within 2, so I had to go up 2 and down 2 from the mean. Okay, so they're all not as straightforward as this is lower, this is the upper. Sometimes they give you a little more you got to work through. Well, I think we're on the same page here. Yeah, shoot, this was an old Regions question. This was a little nastier than the other ones. So we've hit part A. Part B says cookies are rejected if they weigh more than 44 grams, or they're rejected if they're less than 36 grams. Okay, so I think there's like 2 problems tied in there. I'm going to reject any cookies that weigh more than 44. So I've got to go to 44. And where would I shade compared to 44? To the right, because it's more than 44. So I'm going to reject any cookie that falls here. But then I'm also going to reject any cookie that's less than 36. So then I got to start at 36 and reject anybody that's less than it. So I need to get this answer, and I need to get this answer, and then I need to add those 2 together, because it's an or, right? Or in probability means to add. So I need to take this answer and add it to this answer. I'm going to reject anybody that falls in this section or falls in this section. So I'm going to go my normcdf. What was that? 44 or above, so 44 to 999. 40 and 2. And then I'm also going to reject anybody less than 36, so negative 999 to 36. Oh, it happened to be symmetric. So I'm basically going to take that plus this answer to get the total amount that I would reject. And then I would have to multiply that by my 10,000 cookies. So I'm rejecting anybody 46 or 44 or greater, 36 and less. So I'm rejecting 0.045% of the cookies times the 10,000 cookies. So I think I'm rejecting 455 cookies out of the 10,000. Some good quality control. Let me know if we're still stuck.